the basics on shielding of welds. It's a very important principle that we're going to study today, where we are trying to protect the welding pool from any atmospheric contamination or reaction with any of the gases which are present. Myself, Dr. Gurraj Singh. So let us begin. As we know, the primary function of any shielding gas is to protect the weld pool from either the influence of the atmosphere, like oxygen gas which is there in the atmosphere, and nitrogen absorption. And also another very important function of the shielding process is to stabilize the arc, because if your arc is not stable, you cannot perform the welding in a very neat and clean manner. The arc needs to be stable for a proper welding process to take place. The different gases which are present in the atmosphere in relation to the welding process are oxygen, carbon dioxide, nitrogen, and water vapor. So all these four gases, they are not very favorable when they come into contact with the weld pool. So what the shielding process does is that by shielding we mean that we create an envelope around the weld pool, an envelope of a specific gas, which normally is a non-reactive gas, which is an inert gas like argon or helium. So here you can again see that a blanket of argon or helium has been created around the weld pool, and this blanket is going to protect the weld pool from any atmospheric contamination of these gases or even the dust particles. So it's even going to prevent any dust particle from directly coming into contact with this weld pool, and hence it protects the weld pool, thus imparting it strength and preventing it from getting weakened. Now it's very important to study the impact of certain gases which are used as shielding gases. The most famous ones and the most commonly used ones are argon and helium. We are very much aware that argon and helium are both inert gases. Argon is heavier than air, therefore it has a tendency to sink down, while helium is much lighter than air, so it has tendency to flow in the upward direction, to rise up. So we all know that argon, it accounts for nearly 1% of the air, and when we are trying to produce oxygen industrially, it is a byproduct of that process. So that is one of the ways through which argon is manufactured. And the good effects that it has, they include that, this is the gas which is good for shielding welds in flat position and in deep grooves. Now, why do you say deep grooves? Because it is heavier. It tends to sink inwards into the groove and hence provide proper shielding. It is also suitable for easier starts and alternating current applications, as well as for longer arcs at lower voltages. So you can see that there are certain specific conditions in which the usage of argon gas is much more favorable as compared to other gases. In pure form, argon gas is often used with aluminium and non-ferrous metals. So again, you have its application which is done with either aluminium or other non-ferrous metals. And the addition of helium. Now if we add some amount of helium to this argon, what happens is that argon's heat transfer properties, they improve. And if we mix some amount of carbon dioxide or oxygen, it helps in providing a stable arc. So one thing becomes very clear from this is that we can mix several gases or maybe a couple of gases together and use or take the benefit of plus points of both these gases. Now coming to helium, it is effective for mechanized applications but less forgiving for manual welding. And the problem here is that helium, it creates an erratic arc, a very unstable arc. It can result in spatter when working with steel. Now, what is spatter? All those who are studying welding, they should be aware of the term spatter, which basically means that whenever we are trying to perform a weld, the welding rod is moving in this direction, there's loads of droplets, molten metal, which is being spilled out in form of these droplets around the weld pool. So it is called as spatter, and this gives a very poor surface finish to the overall part when you take a look at it after the welding has been completed. And pure helium is ideal for magnesium, copper and aluminium. So these are the three materials for which pure helium is normally used for. And when mixed with argon, helium can provide cathode cleaning. We are all aware of what cathode cleaning is. Next, let us talk about hydrogen and nitrogen now. We know that both hydrogen and nitrogen aren't inert gases, they are reactive gases. And hence, we can say that some reactive gases can also be used for shielding purpose. If not solely, then at least when they are mixed in moderation with the other inert gases. So as it is mentioned here, hydrogen is often used in combination with other gases. When it is added to argon, it can deepen the penetration and increase the welding speeds. So if you want to have a deeper weld, and if you want to have a fast welding operation, you try to add hydrogen to argon gas, which is used as the shielding gas. On various grades of stainless steel that are sensitive to oxygen, it can result in cleaner weld surfaces and better bead profiles. Also, when we are mixing argon, carbon dioxide and hydrogen, so the mixture of these three gases, it can raise the arc temperature, narrow the arc, and improve weld penetration. So these are the three advantages that we get by simply mixing carbon dioxide and hydrogen with argon gas. Hydrogen isn't perfect though if used incorrectly. Now, one thing that we know, that hydrogen gas, when trapped in molten material, and if that material solidifies, it is known to create a defect that is called as pinhole porosity. We've studied that in casting as well. So even in this case, if you're using hydrogen in larger proportions, it is going to cause that gas entrapment, and that's going to result in the formation of round holes, which is a defect and which weakens the weld. Then when I talk about nitrogen, nitrogen increases the weld penetration and the arc stability. And when nitrogen is added to certain gas blends, the mechanical properties of those alloys which contain nitrogen and prevent pitting, corrosion and nitrogen loss from the metal. So those properties can be improved if we are using nitrogen. Next, we come to another couple of important gases, which are oxygen and carbon dioxide. Now we know that the purpose of shielding, one of the reasons why we are shielding, is to prevent the oxidation, and therefore we cannot use oxygen in much larger quantities, and in most of the cases it is not recommended to use oxygen at all. But some benefits which oxygen can provide are arc stabilization, spatter minimization and metal transfer improvement. So these are the three advantages which can be drawn out of oxygen, and that this gas can cause oxidation. However, it can't be used with copper, aluminium or magnesium. So it cannot be used with these three metals. And carbon dioxide, when we talk about CO2, it is best suitable for steel and is especially used in MIG welding. And in that case, it will be called as metal active gas process. So it becomes MAG. And it causes increase in the weld speed, better penetration and improved mechanical properties. And it has certain problems though when you're using it in larger quantities. It causes a shakier arc and it also leads to spatter losses. And another important thing to note here is that while working with CO2, it can produce a lot of smoke fumes on the job site, which is not recommended as per the international safety norms. So therefore this has its own disadvantages, and mixing CO2 with argon, it can minimize spatter. So that's one benefit which you can achieve by mixing it in regulated quantities with argon gas. And carbon dioxide should also not be used for thin metals like aluminium. So here you can see that the addition of various gases or the usage of some specific gases gives you a specific bead contour as well as penetration. So when you use argon, you have a narrower and deeper weld. So that's how argon causes the weld to be. And when you're using helium, it's a very broad and shallower weld. So the bead profile is entirely different from argon when you're using pure helium. When you use CO2 purely, the bead profile is an expanded version when you compare it with helium. And when you're mixing argon and helium, the bead profile is somewhere in between argon and helium. So the intermediate will be achieved. Again, when you're adding different types of gases like oxygen or carbon dioxide, you can see that addition of oxygen to argon, it deepens and narrows the weld bead. Less deep and a bit broad in case of addition of CO2. And when you're using pure CO2, it is a very, very shallow and wide weld. So this is all about the shielding process. In the next video, we will be discussing about the different types of fluxes which are used in welding, especially in case of arc welding.